In this mini-series, I'll be showing you how to take this to-do list app, which was built with React, Hono, and Postgres, and deploy it live to the internet with the application code hosted on Azure and the database hosted with Neon. This to-do list has user authentication with BetterAuth, and it has basic to-do list features like creating a new to-do, deleting a to-do, completing a to-do, and then displaying the to-dos. This video is part one of the series and will focus on setting up our production database for the app. Chapter one is going to be an overview of how the local database currently works and the battle plan for getting the production database up and running. Chapter two is going to be creating the production Postgres database with Neon, which will then be live on the internet. Chapter 3 will be then connecting to our production database with our application and testing it out to make sure everything works. Chapter 4 will then be creating a GitHub action to automatically run database migrations on the prod database. There is a link to the completed code in the comments below, and the code is free to use. If you're looking for a tutorial on how to build this to-do list app, I have another video that is focused on the application code. That video is called Full Stack Auth Tutorial with Hono, React, and BetterAuth, and I'll leave a link to the video in the comments below if that's what you're looking for. If you find this content helpful, please consider subscribing to support the channel. I'm going to give you a quick summary of how my database is set up locally and how we're going to set up a production database. So currently my database is running locally on my machine, and my Postgres database lives here inside of a Docker container, as you can see. Now, looking at my application code communicates with that database locally through this database.ts file. This is where my logic lives here inside of my server folder, inside of the database folder. So my database connection happens with Drizzle. So Drizzle will take this database URL that is inside of the .env file, and this .env file, the database URL, points at my local host 5432, which is where my database is running inside of the Docker container. So in order to deploy this application to the internet, we need a Postgres database that is hosted live on the internet, and that is where Neon comes in. So Neon is a database provider that specializes in Postgres, and they have a generous free tier that allows us to deploy Postgres databases live to the internet very easily. And it just so happens that they work really well with Drizzle also. So if we skim through this documentation really quick, we can see that after creating a database, they'll provide us with a database URL, which we can just plug into the .env in order to connect to the production database. And then we just need to install the Neon database dependencies here, and we can then create a Neon client and plug that right into Drizzle. So this is super easy, super convenient. And what I'm also going to do in this tutorial is configure my database code so that when I'm running my app locally, it uses my local Postgres database. I don't want to be running my local app against the production database. It's important because we can make mistakes and put fake data, testing data into the production database. We don't want to do that. I want to be able to test against my local database and destroy that local database and spin up a new one very easily if I ever need to do that. So with that summary out of the way, our first step is to create a new project in Neon. So I've signed up for a Neon account. I'm on the free tier here, and I'm just sitting here on the dashboard, and this is where we're able to create a new project. And creating a new project is the same as creating a new database. So if I click the Create Project button, we can go ahead and give the project a name. I'll just call it Hono To-Dos because I have a to-do list with a Hono server. And then I'll put this on Azure because I am planning to deploy the application code on Azure as well. And so this could lead to some performance benefits if the code and the database are running in a similar data center. So with that, I can click create. And believe it or not, we now have a database up and running. It's pretty easy, which is amazing. Neon has done a great job here. So now the question is, like, how do we know that we have a database up and running? Well, we can come over here and we can click on the tables. And right now there are no tables, so we just have an empty database. So our next step is to connect to this database and then run some migrations so we can get our tables and see some data inside of here. So to connect to our database, we can jump up here to the dashboard and we can click on the connect to your database button here. And this pops up a modal here where it provides us with this connection string, which is super handy. So I'm going to copy this snippet, and now I'm going to put this into my .env file here in VS Code. So I'm going to want another database URL, and I'm going to comment out that first one because I'll use it again later, and then paste what I just got and just clean up that front end, get rid of those quotes, and now I've got my production database URL here inside of my .env. So that's our first step to being able to connect to our database. And the second thing I want to do really quick is install the dependencies. So if we jump back over to the documentation here, we can come find these dependencies again. So this is what I want, but I'm using bun to install it. So if I just tab over quickly, I can say bun install both of those. All right. And then install this dependency of development dependency, the types for WS, which is WebSocket. There we go. So now I've got everything I need installed, and our next step is to update the database TS file to work with Neon. So now I want to update my database TS file so that it's not just connecting to Drizzle, but it's going to connect to our production database in a production environment, but also connect to the local database in a development environment. So how can we do that? Well, the first thing we need to do is specify what environment we're running in. So here in my .env, this is my local environment. We can say that our app environment equals development. And then in production, we can point it to production. And I'm going to actually point it to production right now because we're testing this out and I want to test that we can actually connect to our production database that's hosted on Neon. So we've got our production database URL here and we're declaring it the production environment. So then back over here, I'm actually going to jump over to the documentation quick so I can copy some of this boilerplate. So if I go ahead and grab all of this and just plug it in up here. So we've got some duplicates. Let's get rid of that. So I don't need that because bun reads the env file directly. And then we've got this issue here, import WebSocket. So we need to import this as a star as WebSocket. All right. And then we have two different drizzles. So that's a problem for us, right? We have the node Postgres drizzle, which we need when we're running locally. And then we've got this one, the neon one, for production. So we can just rename this, and I'll call it neon drizzle. That way we don't have a conflict. And then here, cannot find name neon config. So we must need to import that as well. There we go. Now it's happy. And the comments from the doc say if we're working in an edge environment, one of these, then we'll want to enable this, which I'm not doing that, not deploying to an edge environment this time, deploying to Azure. So that'll be fine. And then this is the code for prod. And down here is our code for dev. So now we want to add some logic to pick either one or the other depending on the environment. So let's go ahead and add a function. We'll say get database connection. And then instead of exporting this, we'll move this down to the bottom and we'll export what we get back from the function. So now inside of here, we can add some logic to pick what environment it is. So first, let's say if process.env.app environment is development, then we're going to use our Drizzle client, our regular Node Postgres Drizzle client. And then give it the database URL. Now, the thing is we need to return something here. So what we can do is actually to optimize this function, as our queries here are going to be fetching this database regularly, we can go ahead and set this up here and say, call it the database client. And then we can set that client here. That way, basically when the first time the app starts up, this function is going to be called, and it's going to set this database client to either the dev drizzle or the prod neon drizzle. So that way it'll save us some compute on this function. And then we can say if there is the environment of production, app environment, then we'll use this code up here, and I can delete that, and instead of exporting this, it'll be the database client that gets returned, and save for formatting. And I'm going to leave this pool here. This is just for dev, but as you can see, this pool is only used in my seed script here, and this seed script is only for local development anyway, so it doesn't hurt us to just leave this pool here so that we can run the seed script for local development. So now jumping down to our code and taking a look at this red squiggly, it's saying the argument of string or undefined. So the database URL could possibly be undefined. And so we can add a little protection for ourselves up here and say, like, if there is no database URL, then we can throw a new error. Yep. And then we'll see that in the logs and we'll know exactly what the problem is. So now things are coming along pretty good. I just missed one thing. So we don't want to reset the database client. So if this function is called for one query and then it's called for another query, um, basically we want to check that if we already have this database client set. So we can say if this is not set and this is development, then we want to create the new Drizzle client for local, and then we want to do the same thing down here. There we go. So now we're getting TypeScript is upset because it's saying, hey, this is an any type. So we want to tell it what this type could be. And what we can do is we can hover over this and we can try and grab the type here. So I'm going to copy this. So this is our Postgres Drizzle client. And let's see if I can import that from Drizzle Postgres. And maybe I can just say that the client here is of type pool. And just clean this up a bit. Okay. And now it seems pretty happy. The thing is that this could be the Node PG database, or it could be the Drizzle one. So if we hover over this, see if we can find the type. And a little bit harder to see. So I am actually already aware of what the type is. So we can add an OR symbol and call this neon HTTP database. And save that. And there we go. So now we can see our database client is either our Node Postgres or our Neon client. Now here at the bottom of the function, I need to return the database client. That way, whichever database client, either the local Drizzle or the Neon Drizzle, will then get set here to this database const, which can then be used throughout the app. And I just realized I forgot to update this one thing here too. So I renamed this to Neon Drizzle. And so this should be Neon Drizzle and regular Drizzle. Okay, perfect. So this is looking good. This should now connect to the appropriate database in the appropriate environment. So we can test this out by running some migrations. So here I have a folder for migrations, and I have several migrations that already exist, and these exist in my local database. And if we take a look at the schema, we can see what those migrations represent. So we have a to-dos table, a users table, session table, account table, and verification table. So I would expect to see these appear in the Neon production database after I run migrations because I'm set up that way to point to production right now. So if I come to the terminal and I do bun run database migrate, we can see it has applied migration successfully. Now let's jump over to our Neon console. And inside of here, if I come over to my tables, there we have it. So we have our several different tables, and they're all empty. There's no data in them, which is fine. But this is success. We were able to connect to our production database and run our migrations. So now I also want to quickly verify that I can still run my app against my local database as well. So if I come back over to my env file and I comment out production, bring back development, comment out the prod URL and bring back the dev URL, and then I go ahead and say I'll run this locally, bun run dev, and I actually have a way to view my local database using Database Studio here too. So we can quickly just verify that everything is still looking good. So go to my to-dos, okay, cool. I'm able to interact with the application here. And then if I jump back and I open up Fun Run Database Studio, this will give me the Drizzle GUI to look at my local database. And we open that up. And we should see these same tables, yep. And we can see the 2 to-dos here in my database and the 1 user that I have here in my local database, which represents what I have here. I have the 2 to-dos. Cool. So I'm able to now either connect to my local database or my production database. So one other thing that I want to do is test this local app against the production database, actually creating a user and creating a couple of to-dos to make sure all of the queries work. So if I come back over to my app, I'm going to go ahead and close that server and then jump over to the env file, and we're going to point this at production again. And now that I have that, I can start the server up again and jump back over to Google. And we can see I was booted out to sign in, which makes sense because the user that I was previously signed in with the local database wouldn't exist here. So there should be no users. So if I go ahead and sign up a new user, all right, so I created a new user with no to-dos, and if we go back to our Neon console and I click refresh, let's see. Okay, there's a session in there. There's no to-dos, which makes sense. I haven't created one yet, and we can see the user, Nick Olson. That's me. All right, so we are seeing a user here in our production database. Now, if I create a couple of to-dos, all right, and jump back over to our prod database, click refresh, and click on the to-dos. Awesome, we can see our production database has been updated. So our application code is working correctly with our prod database, which is awesome. So we can switch back and forth between local and prod, easy peasy. So the last thing that we're going to do here is I'm going to set up a GitHub action that will run our migrations for us in production. And the reason why we're going to do this is because it's actually bad practice to run migrations on your production database from your local environment like I did here. And I did that because we're just setting up this production database for the first time. But when you're working on a team of engineers and people are pushing code to production regularly and migrations need to get run, we can't run the risk of an engineer forgetting to run an updated migration and our database being out of sync with our application code. That's very risky. It would crash the application or cause a bunch of errors. So what we want is whenever a pull request is merged into main, we want to automatically run the migrations. And we can do that with a GitHub action. So in order to create a GitHub action, we can go ahead and add a new folder here. and these are called .github, and then there's another folder inside called workflows. And then inside of here, we can create a new file and call it deploy.yaml. So GitHub Actions are always YAML files, and this will simulate the whole deployment process. But for now, we're just in part one, and we're getting our production database up. So the only thing we need to do right now is run migrations. So to create this, we can give it a name. And then when do we want to trigger this? So I was saying that we want to trigger this on a push to main. So we can do that by saying on push and specify the branch of main. And then we can also add another option called workflow dispatch. And this allows us to manually trigger this workflow if we ever need to do that. So the workflow will be triggered when a pull request is merged into main, or if we were to directly push code to main, which we wouldn't want to do either in a real team environment. We'd only want to merge code with an approved pull request. So then we can specify the jobs that will run here. So we'll say jobs, and this will be deploy. So then we can specify what job runner this will run on. So it'll be runs on, and we're going to do Ubuntu latest. And you might be wondering, where does that come from, this Ubuntu latest? So I'm going to show you where that comes from. Here on GitHub's website, they have their actions and they have their runner images repo. And here they have a lot of information on how GitHub Actions work. So if we scroll down, we can see available images. So Ubuntu 24, the YAML label is Ubuntu latest. So if I click on this to just check out what that means exactly, it means the GitHub action is a virtual machine that gets spun up whenever one of those triggers occurs. And on that virtual machine, we will have the Ubuntu operating system. And we'll have more than that too. We'll also have all this additional installed software. So it comes with Bash, Clang, Dash, etc., Node.js, version 20, package managers. So it comes with quite a bit of software already installed on top of that operating system, all these tools as well. So it's pretty robust. They've done a good job with GitHub Actions. They're very easy to use. So basically, if we jump back over to our YAML, we're going to be spinning up a virtual machine with Ubuntu and all of that additional software on there to help us out. So down here, we can also name this step as deploy. And then specify our steps. So our first step, we need to check out our code. So we can call that checkout. And there is an action that GitHub has already created for us to easily check out code. It's called checkout and currently at version 4. So that will take all of this code and bring it into the virtual machine. Then our virtual machine does not come with bun installed, so I need to bring bun in. So I'm going to label this step as setup bun, and we can check out how to install bun inside of a GitHub action. There is this official setup bun GitHub action created by the bun team. And down here, all we need to do is run this bit of code. So I'll copy that. And I can delete that then. And now my YAML's a little out of alignment there. We can get that fixed up. Okay, cool. So we're going to use the bun action that they have, the official action, and with the latest version of bun. So that is looking good there. And once we have bun installed, then we can run our migration. So if we go over to our package JSON, we have our script here. Sorry, that's the generate one. Database migrate. So this is the script we want to run. And since our application code has been loaded into the virtual machine at this point, with that step, we can now run any of our scripts that we have in our package JSON. So I can specify the name and oh, I forgot a step actually. So it brings in the application code, but our node modules need to be installed. So we need to install the dependencies and line that up. And then we can do bun install. Now we can run our database migrations. And this isn't quite going to be enough because our database migration relies on the database URL in the environment. So how do we get our environment variable inside of here? So there is a way to do that. We can just put environment and then we can say database URL. But now where's the GitHub action going to get our prod database URL from? Well, we can add it in over here at GitHub. If I come over to my repositories and I click on the repo that I've been working on, from this repo, we can go to settings, secrets and variables, the actions for GitHub actions, and we can add a repository secret here. So here I can say database URL, and I can come get my connection string, copy that again, plug that in here, add secret. All right, perfect. So now our secret, our database URL pointing to our prod database is now accessible to our GitHub actions. So we can come here and we can access that secret with secrets.database URL. And that should do it for us. So we can now test this out by either pushing directly to main or creating a pull request. And the thing is, though, I already ran the migrations, so we wouldn't see any change. So let's go ahead and make a quick change, add a new migration, uh, just to test this out. This is basically, I'll add a new column to this table that I don't really care about, but I'll remove that column later. So let's add something like subtitle, and I'll just copy that, and I'll make this optional. So we're just adding a new column to this table, and then I need to generate a new migration from this change. So let's go ahead and I can kill that. Bun run database generate. All right, and check the migrations. And here we're adding subtitle to the table to-dos. Okay, perfect. So now if I go ahead and create a pull request for this, so let's create a new branch and call it connecting to prod database. And take a look at all of our changes. So we installed the Neon database driver there, WebSockets, the types, that looks good. We've got our GitHub action that's going to run the migrations for us, updated the logic for connecting to the appropriate database. There is our new column, and these are the auto-generated kind of metadata and SQL from Drizzle. So that's all looking good. And we'll say, yeah, added a logic to connect to broad database. Commit this. Yes. Publish the branch. All right. And let's jump back over here and go to my pull requests and create a new pull request. And I'll just create that. There's the 8 files that I changed. And I'll go ahead and just merge this. And now this merge should trigger our GitHub action. So if I come over here in GitHub to the actions, so over here in the actions, we can see that there was some kind of error. So if I click into this and take a look at what's going on, it's saying line 18, column 9. If I take a look at column 18 here, we can see, all right, there's the issue. I added an extra dash here actually on row 19. So if we jump back over to the code and I get rid of that, that should fix our issue. So I'm going to go ahead and push this straight to main, not do a pull request this time. Syntax error. Oh, it looks like I made that change on my old branch. So let's go ahead and sync that back. Quickly do that again. And normally I wouldn't push straight to production like this. But since this is just a demo, I'll do it for speed. Sync that back up. All right, now if we come back over here to GitHub and we refresh our actions, there we can see our action is running and our deploy was successful. We can click into this to see our various steps. So these are the steps that we specified in the YAML file. So it's really handy. You can open these up and look at all of the logs for what happened in case you need any additional information. So now the moment of truth. Did our migration run? If our migration ran, then we should see this new subtitle column in our to-dos in our production database. So over here, if I click refresh and I come to the to-dos, there we have it. There is our subtitle column. So our migrations worked successfully through the GitHub action. In summary, we now have a working production database ready to go, and any database changes we make will automatically be applied to our production database via the GitHub action. So this wraps it up for part 1 of this production deploy mini-series. In the next episode of this series, I'll deploy the Hono app to Azure and then connect it to the production database. So happy coding and Godspeed.